Okay, so I constructed a very ugly Galilean telescope. And just to be sure, Galilean telescopes are not ugly, just mine. All right, a Galilean telescope is one where the lens forming the image has positive focal length and the eyepiece has negative focal length. And in some other separate video in the future, maybe I'll explain all that. Anyway, yeah, so in real life, it looks like this. So I really made one. I really made one. It looks terrible, but it works. I'll show you in a minute the magnification and how it works. All right. So what I did was I took a coffee cup and a toilet paper roll, like a used toilet paper roll, like this one right here. See, I used this one yesterday. Used a lot of it. Must have been something I ate. Anyway, then I used a big Fresnel lens and cut it into a square and taped it in front here of this cardboard where I've cut two holes, front and back, where I can insert the coffee cup and tape it up. The toilet paper roll, the used toilet paper roll, can move in and out for focusing. And then I cut out another piece of cardboard and I popped out an old lens from a spectacle lens that has negative focal length. That means it's a lens meant for a nearsighted person. Won't say who. And then I popped it out and I taped it here, so that's the eyepiece, right? And so that's the telescope. All right. So what else? Okay. So by the way, the Fresnel lens you can buy. This is just a magnifier. It's a magnifier, a big, large magnifier you can get from a bookstore. Okay, or any bookstore, maybe some store like Daiso, for example, right? Japanese lifestyle shop. All right. So okay. So uh, it has magnification, all right? Because so to demonstrate that, let me tell you what I did here. Right? I took this, and pointed it at uh, an animal behind me. Let me see if I can do this. Okay, do that. There's Baby Yoda right there. And then aim it. You can see that before I inserted the telescope in front of my webcam, uh, it's it's small, right? When I put the telescope in front of the webcam, which is an eye, which is like a human, like a mechanical eye, it's larger. How much larger? You can calculate that, right? You can calculate that, and here's how I did it. I took a picture and then cut and pasted it onto my screen, like this, and then I used a ruler onto my screen and measured it. It's about 8.5 plus or minus 1 millimeter. You've got to estimate it with uncertainties, right? And then I put the telescope in front of the webcam, which is a mechanical eye, and then cut and paste a picture of it here and measure it with a ruler. It's about 16 plus minus 1. And take the ratio, and you've got to add the uncertainties, right? And so I did it this way. What you do is you take this uncertainty, a fractional uncertainties, fractional uncertainties, to add by the root sum square. You take this ratio, square it, take this ratio, square it, sum it, take the square root, multiply that by 1.9, which is the ratio of 16 to 8.5, and you get this, which is 1.9x plus or minus zero point 0.3, because it's just one decimal place, right? So the estimated magnification is roughly between 1.6 to 2.2, roughly, right? So it works. Excellent. And that's just what I want to show. Thank you. Bye-bye.